Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the elongation phase and as well as the termination phase of the transcription mechanism in case of eukaryotes in detail. So as we all know, in case of eukaryotes, both the elongation phase and as well as the termination phase of the transcription mechanism, they are tightly coupled. So the reason why in one single session we will be studying regarding both the elongation phase and as well as the termination phase of the transcription mechanism in detail. Is it clear? So what exactly happens during the elongation phase and as well as the termination phase? So as I have already mentioned you earlier, during the initiation phase of the transcription mechanism, when the specific RNA polymerase enzyme, by taking the advantage of general transcription factor, when it successfully recruits to the promoter region, it leads to the formation of a specific complex, and that specific complex, it is nothing but what? Closed complex. Is it clear? So after the successful formation of the closed complex, one more other transcription factor, which is nothing but TF2H, it comes into the picture. The specific TF2H, it possesses helicase activity. So as I have already mentioned you earlier, the specific TF2H, it possesses the kinase domain. So once when the specific kinase domain, which is a part of the TF2H, when it successfully recruits to the serine amino acid, which is a part of the heptide sequence of the alpha C-terminal domain, under such condition, the RNA polymerase 2, it acquires the helicase activity. Is it clear? So once when the RNA polymerase 2, when it acquires the helicase activity, under such condition, the RNA polymerase 2, it is capable to unwind the double-stranded genomic sequence so that the closed complex, it successfully converts into open complex. So once when the closed complex, when it successfully converts into open complex, under such condition, the specific RNA polymerase 2, without taking the advantage of primer, it is capable to incorporate the RNTP so accurately. Is it clear? So once when the RNA polymerase 2, when it is capable to incorporate the RNTP so accurately, then after, when the specific TF2H, which possesses the kinase domain, when it successfully recruits to the serine amino acid, which is a part of the heptide sequence of the alpha C-terminal domain, the alpha C-terminal domain, it synthesizes certain transcription factors. Is it clear? So these transcription factors, they play a prominent role for the successful dissociation of the general transcription factors which are in association with the RNA polymerase 2. Is it clear? So once when the general transcription factors, when they successfully dissociate from the RNA polymerase 2, dissociation of the general transcription factors from the RNA polymerase 2 in the presence of certain transcription factors which were synthesized by the alpha C-terminal domain, it indirectly suggests or it indirectly says that the initiation phase of the transcription mechanism in case of eukaryotes, it is successfully organized, because the general transcription factors, they are required only for organizing the initiation phase but not for the elongation phase. So once when the general transcription factors, when they successfully dissociate from the RNA polymerase 2, so it indirectly suggests or it indirectly says that the initiation phase of the transcription mechanism in case of eukaryotes, it is successfully organized. Is it clear? So once when the initiation phase of the transcription mechanism, when it is successfully organized, within no time, the elongation phase of the transcription mechanism, it comes into the picture. That means here we can conclude that TF2H factor, it is not only responsible for the successful conversion of the closed complex into the open complex, and in addition, the TF2H factor, it also plays a prominent role for the successful progression of the transcription mechanism, the initiation phase of the transcription mechanism into the elongation phase. Is it clear? So once when the specific initiation phase, when it successfully proceeds into the elongation phase, under such condition, to organize the elongation phase of the transcription mechanism in case of eukaryotes, likewise the initiation phase, likewise the TF2H factor, the elongation phase of the transcription mechanism, it takes the advantage of one more other specific kinase, and it is nothing but what? PTEFB kinase. Is it clear? So let me write it on the board. So what it is? PTEFB kinase. PTEFB kinase. Is it okay for you? So here PTEFB, it stands for what? Positive transcription elongation factor B kinase. So here the specific PTEFB kinase, likewise the TF2H, it possesses the kinase domain. So here likewise the TF2H kinase domain, when the specific kinase domain which is a part of the PTEFB kinase, when it successfully recruits to the serine amino acid which is a part of the heptide sequence of the alpha C-terminal domain, under such condition the alpha C-terminal domain, it synthesizes certain elongation factors. And these elongation factors, they are nothing but what? TF2S and HSP-T5. Is it clear? So let me write it on the board. So what it is? So here it is alpha C-terminal domain, right? So here the alpha C-terminal domain, it possesses TSP and TSPS. So here the serine amino acid which is present at the second position, it acts as an hotspot for the successful binding of the PTEFB kinase. Is it clear? PTEFB kinase. So once when the specific PTEFB kinase, when it successfully recruits to the serine amino acid, under such condition, the alpha C-terminal domain of the RNA polymerase 2, it synthesizes certain elongation factors, and these elongation factors, they are nothing but what? TF2S and HSP-T5. Is it clear? So what are those? TF2S and HSP-T5. Is it clear? So these are the two elongation factors which play a prominent role for organizing the elongation phase of the transcription mechanism in case of eukaryotes. So here the specific TF2S, it plays a prominent role for organizing the proofreading mechanism. Is it clear? As I have already mentioned you earlier, the specific RNA polymerase enzyme which is processive in nature, it incorporates the normal RNTPs like RATP, RUTP and RGTP and RCTP. And very rarely the specific RNA polymerase enzyme, it incorporates some misincorporated nucleotides. Under such condition, the specific RNA polymerase enzyme, it halts for a certain period of time. The specific RNA polymerase enzyme, it is unable to proceed forward. So under such condition, to overcome the problem, to eradicate the problem, the specific RNA polymerase enzyme, it takes the advantage of a specific factor, and it is nothing but what? TF2S. The specific TF2S, it plays a prominent role in organizing the proofreading mechanism, and here the specific TF2S factor, it is quite homologous to the GRE factors which is used in case of the prokaryotic transcription mechanism. So in the presence of TF2S factor, the misincorporated nucleotide which is induced by the RNA polymerase enzyme, it successfully dissociates from the site of the synthesis. Is it clear? So let me present it on the board. So let us we assume it as the 5' end. And here it is nothing but the 3' end. And it is nothing but the 3' end. And here it is nothing but the 5' end. And here the RNA polymerase enzyme, RNA polymerase 2, it successfully, it has recruited to the promoter region, right? And all these are the nucleotides. Is it okay for you? And here, once when the RNA polymerase enzyme, when it successfully recruits to the promoter region by taking the advantage of certain factors during the initiation phase, and it is capable to incorporate the RNTPs so accurately, as I have already mentioned you earlier. So here all these are the RNTPs, right? RNTPs. So most commonly, as I have already mentioned you earlier, the RNA polymerase enzyme, it incorporates the normal RNTPs. And once when the specific RNA polymerase enzyme, when it incorporates some misincorporated nucleotides, under such condition, the RNA polymerase enzyme, it is unable to proceed forward. Is it clear? The specific RNA polymerase enzyme, it halts for a certain period of time. Under such condition, the specific RNA polymerase 2, it takes the advantage of a specific factor, and that specific factor, it is nothing but what? TF2S. So once when the RNA polymerase 2, when it remains in association with TF2S, under such condition, the RNA polymerase 2, it acquires the endonuclease activity, and it is capable to cleave the misincorporated nucleotide which is induced by the RNA polymerase enzyme. Is it clear? So let us we assume it has the misincorporated nucleotide, right? So here under such condition, the RNA polymerase 2, it takes the advantage of a specific factor, and it is nothing but what? TF2S. So in the presence of TF2S, the RNA polymerase 2, it is capable to cleave the misincorporated nucleotide. So once when the misincorporated nucleotide, when it successfully dissociates from the site of the synthesis, under such condition, the RNA polymerase 2, it is capable to proceed in 3' to 5' orientation in order to synthesize the mRNA in 5' to 3' orientation. Is it clear? So in addition to the TF2S factor, the alpha C-terminal domain, it also synthesizes a specific factor, and that specific factor, it is nothing but what? HSP-T5. So what is HSP-T5? The specific HSP-T5, it acts as a precursor for 5' capping. Is it clear? So let me write it on the board. So what it is? 5' capping. Is it okay for you? So as we all know, in case of eukaryotes, after the successful synthesis of the eukaryotic mRNA, the specific eukaryotic mRNA, it has to export from the nucleus to the cytoplasm in order to participate in the translation mechanism or in the translation process. But prior to that, the specific nascent mRNA, it has to undergo certain modifications, and these modifications, they are nothing but what? Post-transcriptional modifications. So these post-transcriptional modifications, they are nothing but what? 5' capping. Is it clear? 5' capping, RNA splicing, and 3' polyadenylation. So right now we are much more concerned regarding the 3' polyadenylation, but not about the 5' capping and as well as the RNA splicing mechanism, because the termination phase of the transcription mechanism in case of eukaryotes, it is interconnected with the 3' polyadenylation, but not with the 5' capping and as well as the RNA splicing mechanism. So in the next video session, surely I will explain you what is 5' capping and what are the various enzymes which are involved in case of the 5' capping, and what is the specific mechanism which is involved in case of the 5' capping, and what is RNA splicing, and what is the specific mechanism which is involved in case of the RNA splicing in detail. And right now we are much more concerned regarding the 3' polyadenylation, because the 3' polyadenylation, it is in association with the termination phase of the transcription mechanism in case of eukaryotes. Is it clear? So for your better understanding, let me present it on the board. In order to organize the 3' polyadenylation, a specific signaling sequence is required. So in the presence of a specific signaling sequence, both the cleavage and as well as the 3' polyadenylation, it is successfully organized in case of the eukaryotic mRNA. So by taking the advantage of a specific signaling sequence, or by taking the advantage of a single processing complex, both the cleavage and as well as the polyadenylation, it is successfully organized in case of the eukaryotic mRNA. And that specific signaling sequence, it is nothing but what? Poly-A signaling sequence. Is it clear? So let me present it on the board. So let us we assume it has the 5' end. 5' end of the eukaryotic mRNA. So here there is an availability of a specific signaling sequence, and it is nothing but what? Poly A signaling sequence. AAU, UAA. And here there is an availability of one more other site, and it is nothing but what? Polyadenylation site. Polyadenylation site. So let me write it here. And here it is nothing but what? GU-rich element. Is it okay for you? So here the specific poly A signaling sequence, it is responsible for inducing both the cleavage and as well as the 3' polyadenylation in case of the eukaryotic mRNA. Is it clear? So let me write it here. So what it is? Poly A signal sequence. So here the poly A signaling sequence, it is responsible, poly A signaling sequence, it is responsible for inducing both the cleavage of the eukaryotic mRNA and as well as 3' tailing. Is it okay for you? So here the poly A signaling sequence and as well as the GU-rich element, they act as an hotspot for binding of certain factors, and these factors, they are nothing but what? CPSF and CSTF. Is it clear? So let me write it here. What are those? CPSF and the other one is CSTF. So here the specific CPSF, it stands for what? Cleavage polyadenylation specificity factor, and the specific CSTF, it stands for what? Cleavage stimulation factor. So here the poly A signaling sequence, it acts as an hotspot for binding the CPSF. Is it clear? So let me write it here. CPSF. So after the successful binding of CPSF to the poly A signaling sequence, in the very next step, one more other factor, it comes into the picture, and it is nothing but what? Cleavage factor. Cleavage factor 1 and cleavage factor 2. Is it clear? So here the specific cleavage factor 1 and cleavage factor 2, they successfully recruit to the polyadenylation site. So in the presence of cleavage factor 1 and 2, these cleavage factors, they act as endonuclease. In the presence of cleavage factor 1 and cleavage factor 2, the specific polyadenylation site, it successfully cleaves, because for the successful recruitment of multiple adenosine nucleotides at the extreme end of the eukaryotic mRNA, at first the specific eukaryotic mRNA, it has to undergo cleavage. In order to induce the cleavage, a specific endonuclease is required, and that specific endonuclease, it is nothing but what? Cleavage factor 1 and cleavage factor 2. Is it clear? So let me present it on the board. So here it is nothing but the 5' end. 5' end of the eukaryotic mRNA, and here it is nothing but the poly A signaling sequence. AAU, UAA, and here it is nothing but the polyadenylation site. Polyadenylation site. Is it clear? So here the polyadenylation site, it acts as an hotspot for the successful binding of a specific cleavage factor, which is nothing but cleavage factor 1 and cleavage factor 2. Is it clear? So let me write it here. What are those? Cleavage factor 1 and cleavage factor 2. So after the successful binding of cleavage factor 1 and cleavage factor 2 to the polyadenylation site, in the very next step, here it is nothing but what? GU-rich element, right? GU-rich element. So in the very next step, one more other factor it comes into the picture, and it is nothing but what? CSTF. So here the specific cleavage stimulation factor, it successfully recruits to the GU rich element. So as the name itself suggests, cleavage stimulation factor, that means this is the specific factor which is responsible for stimulating the cleavage. So in the presence of cleavage stimulation factor, the specific cleavage, it is successfully organized in case of the eukaryotic mRNA. So the reason why it is termed as what? Cleavage stimulation factor. Is it clear? So here, let us assume it has the 5' end again. 5' end of the eukaryotic mRNA, right? And here it is nothing but the poly A signaling sequence. And here the specific cleavage, it is successfully organized here. So once when the specific cleavage, when it is successfully organized in the presence of cleavage factor 1 and cleavage factor 2, by taking the advantage of a specific factor which is nothing but cleavage stimulation factor, under such condition a specific enzyme, it comes into the picture, and it is nothing but what? Poly A polymerase. So here the specific poly A polymerase, it is a template independent enzyme. Is it clear? So let me write it on the board. So what it is? Poly A polymerase. So let me write it here. So here the specific poly A polymerase enzyme, it is a template independent enzyme. Template independent enzyme. Is it okay for you? So what is the meaning of template independent enzyme? That means unlike the DNA polymerase enzyme and as well as the RNA polymerase enzyme, the specific poly A polymerase enzyme, it won't take the advantage of template. So without taking the advantage of template, the specific poly A polymerase enzyme, it is capable to incorporate the adenosine nucleotides at the extreme end of the eukaryotic mRNA. So the reason why the specific poly A polymerase enzyme, it is termed as template independent enzyme. But here, in order to organize the specific mechanism or the specific process, the specific poly A polymerase enzyme, it takes the advantage of a specific substrate, and it is nothing but what? ATP. Is it clear? So by taking the advantage of a specific substrate which is nothing but ATP, the specific poly A polymerase enzyme, it is capable to incorporate the specific adenosine nucleotide. So here I need to mention you one specific point here. The specific poly A polymerase enzyme, instantly it won't incorporate the adenosine nucleotides here. At first, in the very first strategy, the specific poly A polymerase enzyme, it incorporates a short oligonucleotide sequence. Is it clear? So let me write it on the board. Poly A polymerase enzyme. Poly A polymerase enzyme. It incorporates short oligonucleotide sequence. Is it clear? So after the successful incorporation of short oligonucleotide sequence in the presence of poly A polymerase enzyme, then after one more other specific factor it comes into the picture, and it is nothing but what? Polyadenylation binding protein. In the presence of polyadenylation binding protein, the specific mechanism or the specific process, it is capable to incorporate the multiple adenosine nucleotide. The specific mechanism or the specific enzyme, it is capable to incorporate around 200 to 250 adenosine nucleotides. Is it clear? So let me present it on the board. Multiple adenosine nucleotides here. So in the presence of a specific factor which is nothing but polyadenylation binding protein, it is capable to incorporate 200 to 250 adenosine nucleotide. Is it okay for you? So once when the specific polyadenylation binding protein, when it is capable to incorporate the multiple adenosine nucleotides. So with this, the 3' polyadenylation, it is successfully organized in case of the eukaryotes. So here, many of the students, they get a clarification here. How the specific 3' polyadenylation, it is responsible for inducing the termination phase of the transcription mechanism in case of eukaryotes. So even for today, it is an area of question. So here no one have explained the specific mechanism or the specific process, how the specific 3' polyadenylation, it is capable to induce the termination phase of the transcription mechanism in case of eukaryotes. But here, according to some of the scientists, one specific strategy is available here. So according to that specific strategy, when the 3' processing enzymes, when they were successfully synthesized in the presence of alpha C-terminal domain. Is it clear? So during the termination phase of the transcription mechanism in case of eukaryotes, so likewise the TF2H and the PTEFB kinase, one more other specific kinase, it comes into the picture during the termination phase. And this specific kinase, it successfully recruits to the serine amino acid, which is a part of the heptide sequence of the alpha C-terminal domain. So under such condition, the alpha C-terminal domain of the RNA polymerase II, it synthesizes certain processing enzymes, certain 3' processing enzymes. So once when the 3' processing enzymes, when they were successfully synthesized by the alpha C-terminal domain of the RNA polymerase II, synthesis of 3' processing enzymes from the alpha C-terminal domain of the RNA polymerase II, it reduces the processivity nature of the RNA polymerase II. So once when the processivity nature of the RNA polymerase II, when it decreases or when it reduces spontaneously, under such condition, the RNA polymerase II, it is unable to incorporate the RNTPs. Is it clear? The RNA polymerase II, it is capable to incorporate the RNTPs when it is highly processive in nature. But once when the processivity nature of the RNA polymerase II, when it decreases or when it reduces, instantly under such condition, the RNA polymerase II, it is unable to incorporate the RNTPs. So it indirectly results to the termination phase of the transcription mechanism, or it indirectly inhibits the synthesis of the mRNA in case of eukaryotes. So with this, the 3' polyadenylation, it is capable to inhibit the synthesis of the mRNA during the termination phase of the transcription mechanism in case of eukaryotes. So this is regarding the elongation phase and as well as the termination phase of the transcription mechanism in case of eukaryotes. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.